Welcome to our session on evaluation-driven development workflow. I really appreciate you guys staying with us in the late afternoon. I know a lot of you guys are hiding out, but this is us, so welcome. All right, so today we are going to explore best practices and then real-world scenarios for building, iterating, and evaluating AI agents on Databricks. Before we dive in, a brief introduction about us. My name is Vivian Z. I'm a specialist solutions architect at Databricks within manufacturing vertical. This is my partner, Arthur Dooner.
Hey folks, I'm Arthur. I'm a specialist architect on the same team as Vivian as well. We work building Gen AI systems and workflows and agents together. And the idea is to try to take a centralized way of understanding how we iterate on our AI systems through evaluation as the methodology. That's what our talk's all about. So before we dive really deep into that, we're going to dive first into what are AI agents.
All right, so let's start with the basics. What is an AI agent? An AI agent uses large language model to decide how to call APIs or query data. It reasons based on user requests which tool, function, or dataset to invoke. We often hear systems called compound AI system where you have multiple agents make multiple tool calls, or RAG, retrieval augmented generation, or Genie-style chatbot using text-to-SQL that allows users to ask natural language query about their data, and many more. So in essence, AI agent is large language models, language capability or reasoning capability, plus decision-making, plus taking actions. So now let's take a look at what it takes to run agent-based system in production. What we recommend or the best practices is agentic ops lifecycle. What is agentic ops? Just like traditional software DevOps lifecycle, AI agent needs agentic ops lifecycle. It's a lifecycle that supports evaluation, iteration, and improvement of AI agents. So it all starts from data collection. This is where you might have user inputs, application logs, knowledge documents, or Jira tickets, chat history, and you would like to generate insights or reports for deep analysis. And these data can flow in from Microsoft Azure Blob Storage or AWS S3 bucket, whatever external resources you might have. And the next is data prep. Data prep is when you use tools like Spark, SQL, or Pandas to clean and transform the data for it ready to consume or build or tuning the AI agents. This is where the data engineer plays an important role. For building and tuning AI agents, this often involves prompt engineering, RAG system configuration setup, for example, using vector search for context retrieval, and then decide which tool or functions to call. And you can use your favorite like open source software like LangChain, Llama Index, OpenAI. And this is where you might also be fine-tuning your model or customize your model using TensorFlow or PyTorch. And tracing is critically important in this step because it tracks every step the agent takes and it captures the input and output, cost and token usage, all these metrics. So you can review and make sure that agent gets to high quality.
And that's a really big point on all of this, like training and these AI systems that you're building, because it's not like we're training a model. We're training a set of behaviors through prompting, through agents, through all these tools that Vivian's alluding to, right? And then we're evaluating how those tools are being used in different contexts. Are the tools working well? Are the model prompts working well? Is the mandate of the model clear? Is the model performing safely? We're going to get really deep into all those parts, but you want to review the deployment piece as well?
Yeah. So basically, after you build the agent, we enter into evaluation phase, and this is where you have the domain experts, whether that's human or AI judges, come into play. And once your model passed your threshold and hits the verification checks, it's ready for deployment. And this is where the ML engineer serve the model via model serving, whether that's Databricks model serving or Docker or Kubernetes. But this doesn't stop, the story doesn't stop here. Once your model is live in production, you should continuously monitor the model performance, catching any bugs, any issues, and regressions or edge cases, so to start the life cycle again. So in essence, the agentic ops is not about just getting one prompt working. It's about iterating and then evaluating and then using traces and then helping you build this entire life cycle that you can iterate on to get your model to high quality.
Exactly.
All right, what does it mean to be evaluation driven? And evaluation is a mindset, and evaluation driven, what we mean is that you treat your quality measure or metrics as first class, which means every change, whether that's be prompt tweaks or model upgrades or new tools you added into your system, you verify them in a repeatable and standardized way. And every evaluation run, before you run evaluation, you should have a clear defined success criteria. And this success or this correctness should be catered to your business use case, aligned to your business goals. And what is correct in one system might not necessarily be correct in the other system. And then you need to compare your new versions from the previous version to know whether you're moving forward or backward. Without evaluation, we cannot prove that our iteration is making any progress.
And one of the big things about these foundations is you look at the tooling that Vivian's about to present, I want to make it really, really clear that those are templates and scaffolds to accelerate how you train and build these AI systems. How you design your system to solve each goal, the technology that's on the newest versions of MLflow 3 that got announced this week at Data and AI Summit, right? We want to recognize that these are ways to help you get started evaluating these AI systems. They aren't necessarily the end all be all. There's going to be nuance to the ways that you build your AI system, or like quality metrics or heuristics or judges that we'll all dive into in a second. But just think about that. You're using the MLflow technology as a template to extend judging your own AI system. Does that make sense? Hope it does. Vivian.
Yeah, so the types of evaluation we're talking about here is, and this circles back to my point earlier about you should be able to build your system that caters to your business use case, aligned with your business goals. And accuracy and correctness may mean different things in different AI agent systems, in different systems. Like for example, in traditional machine learning, you have classification and you have advanced score, RMSE. And this is where you might also be able to apply it in your agent Gen AI system, where you need to do some classification or some sort of like task that's related to this aspect. And in RAG system, you might highlight on the retrieval performance or retrieval quality, prompt expansion, latency, costs, so on and so forth. For agent system, you want to highlight that whether that agent is deterministic or the tool quality and performance individually, as well as the tool results together.
You're taking a big step on the agent side, where everything becomes less deterministic, right? You can kind of view this whole slide as a spectrum of very tangible, exact answers, right? To very dynamic, unstructured, you have to extract features out of that data or ask questions about what the LLM judge did. So it ends up being this really like, the nuance increases as you approach the further right sides of this visual.
All right, and then the top customer challenge we have heard over and over is, how do I get my Gen AI system to be high quality, deliver accurate results? And quality is hard. Quality is the #1 blocker for productionizing your Gen AI applications, because LM agents are non-deterministic and unpredictable, meaning that you can have small prompt tweaks but wildly different outputs, or you can have different parameters like temperature or some different parameters that add variability to it. And user inputs can also come in conflicts with user can ask the same questions with many different formats. It's also unpredictable and then change over time. Quality is also defined vaguely and in many different dimensions, such as accuracy, correctness, or fluency, or professionalism, right? There are many moving parts in the system, for example, large language model, retrievers, and tools. Why are Gen AI eval so hard? And as we mentioned, user inputs are free-form text and constantly changing. User can ask the same questions in many ways. And user can also have like different synonyms or paraphrases or slang in their language. And the outputs are also plain language, so it has the same problem. It's also free-form text, so judging accuracy is very difficult. To bring it all together, for evaluation-driven development workflow, we really want to focus on these different components. And for each of the components, we're going to dive deep into it later. But for evaluation-driven development, we, throughout this whole life cycle, we want to focus on run repeatable and then standardized tests and have a clear definition, success criteria, and be able to compare between versions. And that's what we mean evaluation-driven development. That's what evaluation drives development.
Exactly. And as Vivian's about to show right now, imagine you built that first agent system, right? You've running your first questions against that AI system you've built. What's the first thing you're going to look at? You're going to look at all of the things that that AI system generated, or the retrieval pieces it called, or the tools it called, and you're going to see that through tracing.
Yeah. So let's dive into ML tracing. What is ML tracing? ML tracing provides end-to-end observability. It provides all of these features that help you get the Gen AI system you build to high quality. It has streamlined debugging, every step of your Gen AI applications. You can quickly diagnose and resolve issues. Offline evaluation, you can use our proprietary technology for LM Judge to do agent evaluation, and then you can measure improved agent quality over time. Production monitoring. It allows you to monitor the agent behavior or actions it takes in production to optimize the agent performance or capture any regressions or edge cases or errors happening. So you have confidence that your agent is working properly in production. Audit logs. So tracing also generates audit logs for agent actions and decisions. This also allow you to use these logs later for review or edit and understand the quality of your application. And now you see a UI interface of ML tracing. This is just showing you on the left side, you can see like the trace breakdown of the step that the agent takes, whether that's tool calling or the input and output. And on the right side, you can see all of this information that's being captured and visualized with inputs and outputs and the latency. ML tracing is also standard and interoperable. You can trace 20 plus libraries by one line, and it's also built on open telemetry traces. It's an open source software used by the broad community.
So it's kind of funny, right? Like, you might think when we show you that trace, it's like, oh my God, I've got to like set up all of these different pieces that integrate all of these different frameworks, or all these different AI systems I've already built. No, it's literally that one line of code where it will start to auto-log, and you can even like bundle models or like logical entities wrapping all of your models. And it's that trace that we just showed on that last slide, you're literally seeing all of the steps that it's automatically understanding because it has those deep integrations to those frameworks. So it's something that you can basically turn on. I wouldn't say for free in a sense of effort, but nearly free, right? It's just like, okay, enable MLflow, make sure MLflow is working. I have a tracking server hooked up, which is automatic in Databricks, and you're off to the races.
Awesome. And now let's talk about building. And as we talk about a lot about like building and tuning agent earlier, you can use any of your favorite open source frameworks and iterate on the POC. You know, whether that's LangChain, Llama Index, OpenAI, Autotropic, anything you can use and choose which are integrated with our MLflow, you can use and choose to build your AI agent system. And this screenshot is showing you how easy it is to debugging with tracing. You can see the exception details are being captured in the events, and you can use that to debug. And then with the inputs and the call tree, it shows that you can debug very easily. All right, and let's talk about human feedback and why human feedback is so important. I'm going to talk about like with some customers I met. They always say, "Oh, we know that human feedback is super important, but our SME or stakeholders, they just don't have the time to do it or to review the output of the agent systems, right?" And MLflow tracing provides a review app to collect human feedback from your stakeholder, from your SMEs seamlessly and easily. And you will see example later in the demo.
Exactly.
So for this screenshot, you are seeing that this is capturing like the user input and the system output in the same place with the human and AI judge feedbacks. And then here, imagine this would be your production trace where you have a user input and the MLflow tracing that shows each step the agent takes and a system output. And you can see like the assessment to identify the root causes from ML judges and the human annotations. And you can send this trace for SME review and dataset curation later.
And if you had used all of our MLflow tech even a week ago, right? What you would have experienced is I have all of this trace in one place. How do I look at an aggregate of that trace and like similar traces or similar questions that someone asked? Or how can I go look at the human feedback? All of that was very segmented in a lot of different zones because the like foundational structure of MLflow was a little different. It was every experiment was the logical grouping. Every time you run something was the logical grouping, rather than every model, every like key entity you're designing. So there's been this shift in MLflow around those model IDs as that like central entity that we can add all those additional like human traces, human feedback, AI judge feedback that we'll go into in a second in one place, and you can aggregate and see those together.
Yeah, and this game is showing you what the review app looks like. You can see it's very easy for your stakeholders to interact with this app and to provide feedback on expected facts or guidelines or metrics to the user input and the system output. And the stakeholders can just go into this app, open it up, have a conversation, and review the answer and provide feedback to it. It's all about collecting the human feedback and then send it later for SME labeling.
If you want to build that into your own front end too, right? You might be like, I don't want my users to see something that like is in Databricks for testing. I want it to be like embedded in how they're consuming the model anyway. You can actually tie into that endpoint that's auto-deployed with every MLflow deployed model.
All right. And now let's talk about automatic evaluation. So this is what we used to call Mosaic AI agent evaluation. It's advanced and research-backed techniques that allow the developers to quickly evaluate the cost, the quality, or latency of your AI application to do further analysis and improve the agent performance. So as you can see, it's just as easy as putting up a one line of code to do the MLflow GenAI evaluate and then pass the data set you want the LM judge to evaluate on and define the scores that caters or customize to your business goals. And in this screenshot, you can see like you can just use this decorator syntax to define this customized evaluation. You can also provide guidelines for the LM judges. For example, the agent must be, or the response must be in English, or the response must be clear and cohesive and concise, and things like that.
And a lot of the teams that we've worked with, we would build these evaluations. We'd build them very manually And it was extremely painful to design custom evaluations in MLflow, again, up until last week, where it's a lot more intuitive. It's built into, again, those like model app objects. So you just define custom scores for each. So this is another really big change to help you evaluate these AI systems in a lot more custom ways without the infrastructure getting in your way.
Exactly. Yeah. So in this screenshot, I want to show you something that's really special. Like we provide this feature for ML tracing because it's not just capture internal GenAI applications. You can use it with external applications, whether that's application beyond Databricks apps or some external servers. You can use MLflow to capture the traces, which has a user input and output and all these different metadata, and then create evaluation run on it. So as you can see here, you create an evaluation run and specify or select the AI judge you would like to run, whether that's be correctness or relevance or hallucination, like these different metrics, or providing your own customized AI judge or creating your customized metrics. You can use this to run the evaluation on these traces for getting the applications to evaluate and understand the quality of your GenAI applications. And now this would be the screenshot you probably would like to capture for later reference, because with MLflow 3.0, you will be able to view and compare evaluation results across agent versions.
And like something to just note on all this, like as we see, like each one of these is a dimension of a built-in grading feature in MLflow, right? Like the correctness, which is against a ground truth. The context relevance was the context that was provided enough to answer the question. And you see towards the end, you start to have more custom judges that you would layer it past these. These are, again, AI judges that are grading the answers of each of these responses. And you can combine them with heuristics, which are like, oh, tell me, like, what about this answer? Like, how long was it? How many characters did it have? What was the variance? And custom judges. And on that last screen that Vivian just showed, all of this you would used to have to do with code, but with the launch of Databricks and MLflow 3, again, the release this week, you're seeing an ability to be able to do this in the UI. And what's so novel about Databricks that like kind of gets buried in the whole keynote is that it's creating a lot of custom evaluations for you to make the AI system better and better on its own. So that's how it's like different from a lot of those low code systems like AI, Microsoft Copilot Studio and such.
Yeah. And the MLflow tracing has a new feature come out that allows you to do prompt management, so conversion and reuse prompt across agents. You can also automatically optimize your prompts by leveraging DSPy. So as you can see on the screenshot, you can just run this SDK like optimize prompt. It will allow you to optimize the prompt under the hood. And this screenshot is showing you that you can also view and compare agent versions and different versions of prompts, and then see how your agent system like evolve over time. All right. In terms of once your AI application is in production, you also need to know like how is it doing? Is it producing any inaccurate results, or is it having any edge cases or regression happening? So this this feature allows you to do that. So you can run the traces on your production application, and you can use the same custom scores that you defined with the offline development, use it to use for online monitoring. And here you can see that you can review the evaluation results again and identify the bottlenecks or the issues and the root cause to fix it later. All right. Monitoring is a very important part. We would like to continuously monitoring our GenAI applications, and MLflow tracing is providing this monitoring capabilities. You can just configure a monitor on your serving endpoint, and then you can use the same like ML judges that you built, reuse the same scores between offline and the production environment, and then there you can run the monitoring on your data set with the same set of evaluation that unified across offline and online. You can also see there's a dashboard generated with the monitoring capabilities, and here you can see the operation metrics and the request latency, and also the assessment scores that you defined earlier. And you can click on each of the diagram or each bar to deep dive and then take a further look at the issues or things that are happening there. All right, and you can also capture like the monitoring results into the Unity catalog table, like secure governance, production traces with Databricks Unity catalog, and for later analyze with SQL dashboard, just like any other business data. And finally, dataset collection. You can create a dataset and export these traces to this dataset in Unity catalog for your SME or stakeholders to review and edit. And then again, once you run through this life cycle, you collect this data, you can put it as your ground truth again, your context, your information that you want to get insights from it for deep analysis. That's what we call you complete the agent ops life cycle.
So thanks so much, Vivian.
Yeah, all right.
Appreciate the overview of all this platform tooling and the view that we have of Databricks and where we see this technology going. I want to make it very clear that the Databricks platform builds a set of tooling for all of us to be successful. As you are building these AI systems, we are no longer grounded in these root mean squared error, like a regression problem classical ML might have. We are now in the wild west of having to think about, well, what does good look like for my application? How would I grade it? How would I know this is good? What Databricks is trying to do with this whole MLflow stack is to support the largest number of people to have a template to grade and assess their AI systems out of the box. From a correctness perspective, if you provide a ground truth. From a groundedness, like, hey, is it using the right context? Those are pretty common generic grades. Is it safe? Is it saying mean things about Arthur after the session, right? Those sorts of things, we need to be very thoughtful about. That's a great template. That's a great place to start. But how do we extend it? And a lot of us approach it backwards. We think, what are the metrics that I need? Or like, what are the questions I want to ask? When really we need to be starting from, what is the problem I'm trying to solve? What are the types of scenarios that I might face? And what's like the base data set of a good question and a good answer that we might be looking for? So what I'm trying to convey here, I'll convey it in a whiteboard real quick. So I love working on cars. I'm not good at it, but I love it. And I've worked on a lot of different cars and like gone through all these like manuals that would tell me, hey, to actually repair this part, you have to repair another part, right? You have to first take this other piece off. So that network graph, even in these like ancient books on old cars, is present and important. But if you're just using like a regular RAG, that context might be lost. So as I think about like any problem, let alone this very specific, silly one that I'm bringing up, there's a question or a task and an answer or an outcome that you need the AI system to solve, right? You need to think about it in that lens. And I challenge y'all, as you build your first AI systems, right? Think about it in those ways. What are the questions my users are going to ask? You might already know this. You might have to go ask them. You might have an idea of it that will evolve. The questions and the answers are going to change and rapidly change or rapidly evolve as we see more and more users like try this out. Oh wow, I never thought I'd get asked this question. Or we're not going to support that question yet, so we need to put a guardrail to say we're not interested in solving that, right? So when I ask it, like, I think about repairing silly old cars. I'm like, tell me about how to replace the front suspension strut of a 2003 Pontiac Aztek, the ugliest car ever made. We think about like, what is that? The first version of the system that I build might just like pull the raw pages from those docs. It'd be like the section that talks about suspension struts. It's like, okay, take those 3 bolts off, right? But you would miss the whole context of actually first you need to take off the windshield wiper assembly. Ask me how I know. And that context is lost if there isn't like a network relationship of those data. The tools that I designed, the data ecosystems, are not big enough in this data domain when I get started to just like focus on these small slices to solve this problem. I need to build that knowledge graph of all of the relationships of the parts that I might need to take off or change or upgrade, or all these different edge cases that exist in an automotive repair scenario, right? The complete answer is like, hey, you actually have to take this off first, you have to disconnect the battery, all these related pieces before you approach the problem. That's signifying what tools you need to solve that task, right? And there are attributes of that answer that you can grade, right? So sure, there are simple versions of this where it just pulls like that first doc on struts and how they relate to other things. But there is a second version of this, how all these components are related. That it's a more compound tool, but your grading, is it traversing that network relationship of data? Is it going to actually bring up that it needs the windshield washer assembly removed? It's easy to think about this if you think about it in tangible examples that are related to your business. It's hard to think about it in the abstract. So the best way to do this is to just start listing out all the questions, all the tasks you needed to solve. And then you start to think about what does a good answer look like. And then you deconstruct what are the components of a good answer, right? You have this idea, what is the groundedness? What are the attributes that make this a high quality answer? And then that becomes your template. You use the MLflow template and you extend it broader than just that set, right? So as you're building these AI systems, we might think, I build a first version of an AI app. This one's an SEC knowledge bot. We build this first version of it, and what's going to happen is I built a few tools. This is what I think that I need to solve, and then I run it through all the questions that I needed to ask. And that's where that GenAI.evaluate comes through. You have that list of like 20 or 30 questions that you're thinking about. Those 20 or 30 become the starting set that help you improve the system step over step. And having that correctness, ground truth, that's why that's the most important one, because it tells you, is this the accurate number? Is this the accurate result? It might be collapsing and losing some of the dimensionality and how the other pieces are working, but it's the most important piece. So if you can start with the ground truth, please do. So you can see it's going to be calling all these tools. We can get all this feedback, and it's not just me sitting in a vacuum getting these results and knowing that I asked this question. It's actually like, oh, it's traversing all these different data. It's an agent. These are the actual results about 2023 and 2024 that I asked about. And then it includes all the context and sites. And I can say, oh, this was a good source. That was a bad source. You can see it right here. Like, this is a good one. Okay, maybe it doesn't want to visualize live demo problems. You can edit the response. You can say it needed to change. And then you can say, like, this was a great answer because it was helpful, it was professional, it was relevant. You can give free text feedback. Same on the other side. No, it wasn't helpful in these ways. And then you build that data set at a very small scale of 20 or 30, right? You're building that data set of just a few examples. Like, you have an idea of what are the tools, the components, the pieces of the system that I need to iterate on. And how do you dig into that beyond the scale of one? Well, that's where some of these grading pieces come in, where we actually capture all of these in what's called an inference table in Databricks. And that inference table is the base data set, right? That's capturing every single question, answer, and then grade that I give later to the system. So there's going to be an assessment log, and there's going to be a request log. And as you get more of those from either you testing it or your end users, you end up with this view of like, wow, I've got a lot of questions that people ask me. And then I can use that to improve my system over time or grade it later, right? Even on future versions of it, as it's a more complete and comprehensive system. So we're thinking about this in a very iterative way, but we're building the data set to grade it from the get-go, from the very beginning ourselves with our subject matter expert feedback, and then we're also grading it against LLM judges to help us understand like the dimensional components of how well it's working, right? So we think about, as I build this system, as I've got people testing it, I'm going to eventually end up in this spot where I've got all of, this is a customer service app, so it's going to look a little bit different on the questions. But you can see like, how is the answer? Is the correctness good? Is the groundedness good? Is the safety good? Groundedness, again, being like context related to the answer. Is that relevant and is it using that context? The safety, obviously, is it saying something harmful? The context efficiency. You can see there are a lot of them, like I didn't hook up the context efficiency piece of this system, and I'm sure you won't the first time either on your first AI system. But having a ground truth, it will highlight all of the ones that failed, because that's really the ones that you care about on each of these pieces. And you can see, like, you can dig in, like, why is this one actually failing? And it's going to say, these are the attributes of it failing. There'll be a trace that you can click into, and that's what we were showing earlier on the slides, that you can filter to certain types of questions that people might have asked. Hey, who asked about Pontiacs? Who asked about Oldsmobiles? You can find those edge cases of different types of questions and answers that people are getting. And we end up with this view of, when I have these maybe specialized business users who we might be more skeptical of this whole AI system thing, we want to make sure we can support their edge cases, or at best, deflect those questions. Say, hey, we're not here to solve that yet. That's part of our backlog. By you asking that question, we've now got it in our list of questions, and we can see if there's any new types of questions we might want to support in the future. So evaluation is a journey, and it's a mindset. Your evaluation is the place that we like to start when we're building these, because we have an idea of what good looks like, and we can define those different dimensions. But then we're not just statically using that evaluation, it's evolving with us. As there are new features of our application that we add, we're going to add those features as components in, right? This is a journey in evaluation, and as much as you improve the app that you are building, you are also improving the actual AI system's evaluation itself. The MLflow starter points are, again, templates for you to extend. So let me talk about how I've worked with a few teams to build some custom AI evaluations against AI systems that they have made. And if you got questions, you can hop on that line at one of the mics, and I'll be more than happy to answer them when I'm done talking about these few scenarios. So if we think about this, very common scenarios, these customer support use cases. Lippert is a customer that I've worked with quite a bit. They're working with progressively more data domains all at once. So they start with like a very small subset data domain. They ask it a few types of questions. It works really well in that. It builds user trust. We can evaluate that it's going to work well because we're assessing across the dimensions that the business users would care about. So that one's a pretty typical standard, very aligned to the template that MLflow might use, right? Then, as we think about our customer needs, right, it's not just building and deploying and governing. We need to monitor these more as we run huge sets of data. The Lippert one is more of a like customer service, probably a couple requests an hour scenario. What happens when you get a case study where you might have technician notes from an automaker or a tractor company? That ends up with a ton of unstructured text. It's a huge mess. Everyone's writing it slightly differently, but you're trying to extract value out of it. You're trying to get some insights about what these technicians said about the cars or tractors that you're working on. So what do? You say, all right, we need to understand if someone mentioned tires in that technician note. You need to understand, did someone mention brakes? Did someone mention, any of these different components of the vehicle? And we can actually mine that out, and we can say, okay, that looks good, and then we can compare it to how we manually graded a set of 100 of them, right? Let's go through and manually grade 100 of them, see, okay, did they mention tires, did they mention brakes, did they mention these other things? And then that can be just a classification score. That's just an F1 score. That collapses to one number, right? So you can just compare. This version of my AI system was 50% accurate because compared to the labeled set that I started with at 100, it was 50% accurate. And then the next version with a better prompt, it's 70%. Oh, with more tools for more context, it's at 80%. See the journey that lives here. And in this scenario, in this big batch process, we're collapsing the accuracy down to these very distinct numbers. We're building up our confidence to rely on this in production at a much bigger scale. And then we can audit this process as we move forward. Further, I've worked with a lot of teams that have built AI systems on their own without Databricks, and then they actually we don't know how to assess quality. These other platforms like AI Foundry, Bedrock might not have those deep evaluation integrations that MLflow does. So people bring their AI systems to Databricks. We don't really change them. And we'd like to, but we don't. We will take those in and we'll actually work with them to design an evaluation. And then we'll compare how does it maybe a new version of that in Databricks work that's running multi-agents, running agent bricks, and see, is it at least as good as the one that Microsoft, the one on Azure, is working? Is it okay compared to a ground truth? How is this? Across all of these edge cases with synthetic data generation for like representative questions of what our business asks, is that going to work? And we obviously have those LLM as judges. And I know I'm over time, so give me like 10 more seconds. Those SQL prompts end up even going as far as we can label specific features of SQL questions. Did it reference the right table? Did it reference the right columns in those tables? Did it do a join? Was it supposed to do a join? We can collapse those attributes into some very clear tasks. And these are very deconstructible problems that are a lot more approachable, but you have to think, what are the components and features that we need to extract from our AI systems so we know that they are working well? So I'll leave this one for as big takeaways for that I hope you got away from today. Feel free to screenshot that. It's a mindset. It's a way that you're viewing all of these AI systems. It's how you iterate and evolve and how you view the problem space that you need to work on. And Databricks helps you with all of these templates, all of this auto-connecting technology. Think like a data scientist. You need to choose the metric. You don't have that metric anymore, right? It's not pre-built for you. So think about how you would design a metric that means something to your business use case. I really appreciate y'all sticking with us late on a Thursday afternoon. Thank you all for your time.